Good day, I am Primo and I will be teaching you on the use of T2000. The next test that we want to perform now is the ratio test and polarity test using current as one is supposed to use, that is injecting primary current and measuring the current to the secondary side. For the secondary side connection, so I will connect where? You see, this is the current metering input, okay? This is going up to 10 amps, so as we have 5 amps with 300 amps to the primary, I don't intend to generate 300 amps. You will see that we can perform the test without high current. For the primary connection, I use this cable with this connector here. I connect it here, this way. As you see, the cable here is quite thin, so it is not done for high currents, but we will not use high current. So this is one. This is the other one. And here we are. Now, I have selected the ratio, polarity and button. I enter. You see, primary current is already there because I left it programmed. Well, here you see there is an option. If you want, you can avoid opening the secondary side of the current transformer and use this clamp this way in order to have the measurement coming from the clamp itself. In this instance, you have to check enabled and input here the ratio. For instance, this is the clamp 1000 to 1. Okay? Next, that's it. I can just start the test, press on, and again here you are. You see, even also in this instance, I have a very small current, and this is the secondary current, and you see the ratio is already very close to 60. So again, it is not necessary to go up to the nominal current to perform this test. You can stop at any current, but when you are with a ratio error that is small enough, like here 0.304 and so on, you can press save, and that's it. Now I go back again slowly, and I stop. Now we are still in the same selection, but I have moved to the burden selection. In this test, we want to measure the burden that is made of all the loads that are on the secondary side of the current transformer, that is here. Okay? I pretend that this resistor here, it is rated 1 ohm, is just this burden on the secondary side. What I want to do now is to put in series the burden to the secondary side of the current transformer. Okay, so I remove one wire, I connect it here, and take another wire and then connect it here, so that the secondary side loop is closed. Now, as we want to measure an impedance, we not only have to measure the current on the secondary side, but also the voltage drop across the burden. Okay? So now I connect the clamps, the cable that you already know, this way. So here I measure the voltage drop, and here I measure the secondary current. Now I press on, and again I repeat, you see, I have immediately some current on the secondary side, some current on the, some voltage measured on the secondary side. The angle between current and voltage, you see, is 360, so that is, they are in phase. The power factor, therefore, is 1, and this is correct because this is a resistor. And you see, the resistance is not measured in ohm, it is measured in voltamps at the nominal current. That is, even if we have a very, very small current on the secondary now, the voltamps rating is almost accurate because with 1 ohm at 5 amps it is 25 voltamps. Okay? Anyway, let me increase the current just to show you. Okay? For instance, now I am half an amp, it is 30 amps on the primary, and you see again the voltamps rating didn't change. Why? Because again we do compute the resistance and we multiply this resistance by the square of the nominal current. Okay? Next selection is Barden secondary side. Barden secondary side means that we don't inject current into the transformer, but into the Barden itself. So this is my resistance that is simulating the Barden. What we do in this test is to inject a current directly into the secondary connection cables. In this instance, of course, we don't need a high current generation. So you see, the current range that I can select is either 40 or 10 amps. I select 10 amps, you see the red light, and I connect to my resistance this way. Okay? Next, again, as before, I have to measure the voltage drop across my resistor, and this is what I do. So with the same cable, I can measure the voltage drop, and again, the test set will do what? Will measure the resistance and compute the voltage rating.